The first one at the top, 3, 9, states, if two lines are parallel to the same line, then they are parallel to each other. So looking at the picture, based on the markings, A is parallel to B, and B is parallel to C. So since A and C are parallel to the same line, then these two lines must be parallel. So down here on your conditional statement, if A is parallel to B and B is parallel to C, then we can say A is parallel to C. On the blue poster, it's number 6. If two lines are parallel to the same line, then they're parallel to each other. Two lines parallel to the same line are parallel to each other. Think about like the ceiling dividers. This line is parallel to this one, and this line is parallel to this one. Therefore, those outside lines have to be parallel. Two lines parallel to the same line, it got to be parallel. It is almost just like the transitive property. Good. A is parallel to B, and B is parallel to C. They're both parallel to B, so they're parallel to each other. Theorem 310. In a plane, if two lines are perpendicular to the same line, then they're parallel to each other. What does it mean if two lines are perpendicular? Anybody? They make 90-degree angles, right? So in my picture, I have T, the transversal, perpendicular to M, because they're making this right angle, and T, the transversal, perpendicular to N, because they make a right angle. Since these two lines, M and N, are both perpendicular to the same line, then they're going to be parallel. And down here, M is perpendicular to T, and N is perpendicular to T. Therefore, M is parallel to N. Another way you could see that is my two right angles that are marked. How could I classify them as one of these 5 we've been working with? Corresponding. Are they congruent? Yeah. So if corresponding angles are congruent, what's it say about the lines? They're parallel. So that's another way you could see this image. Or if two lines are perpendicular to the same line, they have to be parallel. And that's this last one on the poster. Two lines perpendicular to same line are parallel. Got him? Just set it in the basket for me. Thank you, ma'am. All right, and then this last one, 311. In a plane, if a line is perpendicular to one of two parallel lines, then it's perpendicular to the other. So L is parallel to M, and L is perpendicular to N. So they make this right angle. These two lines are parallel, and N is my transversal. What kind of angles are these two? Right angles, but how would I classify them? Corresponding. Since the lines are parallel, corresponding angles have to be what? Wouldn't that make this a 90-degree angle? And if two lines intersect to make a 90-degree angle, we say the lines are what? Perpendicular. If L is parallel to M and L is perpendicular to N, then that means M is perpendicular to N. If a line, N, is perpendicular to one of two parallel lines, so it's perpendicular to L, then this line has to be perpendicular to the other parallel line. And that's based off of the corresponding angles postulate. All right. Theorems. The more of them you know and understand results in fewer steps in proofs. The worksheet that you just handed in had a proof on there. I'm not going to get this completely correct. I don't know, something like that. And it asks you to prove that 2 is congruent to 7 when these lines are parallel. Some of you probably put your given, as you're supposed to. And then you maybe said angle 2 is congruent to angle 5. Why? Corresponding angles. And then you said angle 5 is congruent to angle 7. Why? Vertical angles. Since 2 is congruent to 5 and 5 is congruent to 7, what does that say about 2 and 7? They would be congruent by substitution. Not wrong. Correct. But since these lines are parallel, how would you classify 2 and 7? What do we know about alternate exterior angles? Done. The more proofs you know, more theorems you know, the smaller your proofs get. Theorems act like shortcuts. I wouldn't have had to explain all this. I could have jumped right to it because we had a theorem that related those angles. So if these 3 theorems today are going to act as shortcuts in your proofs. You don't have to know them to prove lines parallel because you guys know how to do it these 5 ways. But if you do know them, it just takes up fewer steps. Capiche? Capiche, cool, all right. First proof. Given K is parallel to L, K is parallel to M, and the measure of angle 1 equals 90, we're going to try and prove that the transversal is perpendicular to line M. So first step, we're going to copy down our given. And after you write it down, you want to mark your picture. So K, the top line, parallel to L, the middle one. You can use feathers or triangles. K, the top line, parallel to M, the bottom one. Make sure you use a different set of markings. And the measure of angle 1 is 90. That one's already marked for us. We're going to prove that the transversal is perpendicular to line M. Do me a favor, name your transversal T. Cross off what we're trying to prove and write it geometrically with symbols. T perpendicular to M. All right. Any thoughts on how I could get T perpendicular to M? You got a lot of stuff there. You got 2 sets of parallel lines. You got a right angle. Maybe read through the theorems that we just talked about. The top theorem says 2 lines parallel to the same line are parallel. The second one says 2 lines perpendicular to the same line are parallel. Third one says that if you have parallel lines and a transversal that's perpendicular to one of them, then it's got to be perpendicular to the other one. What? Any thoughts? Number 2? That one says 2 lines perpendicular to the same line are parallel, right? What about 3? If I have parallel lines and a transversal is perpendicular to one of them, then it's got to be perpendicular to the other one. You like that one more? You like that one more? Okay. So my transversal is perpendicular to which parallel line? Okay, that's given to me, right? We want to prove that T, the transversal, is perpendicular to which one? M. The theorem says that K and M would have to be parallel in order to use that. Do we know if K is parallel to M? You do? Oh yeah, we do. Yeah. So, do we know if T is perpendicular to K? Does it say that? Does it show that in the picture? Does it say it in the proof? Okay, then we have to make sure we say it. Because it shows it, because they make a what kind of angle? And by the definition of perpendicular lines, 2 lines that intersect at a right angle are perpendicular. So K is parallel to M in my given, and K is perpendicular to T. So my transversal is perpendicular to one of these parallel lines, therefore it has to be perpendicular to the other one. Right, Brady? Yeah, thanks for nodding along. T, perpendicular to M, we're using that third theorem. Do you see how it doesn't say like theorem 311, perpendicular theorem? It doesn't have a name. You have to write it all out then. Yeah, I know, right? If a line is perpendicular to one of two parallel lines, then it's perpendicular to the other one. Well, sure, symbols. Maybe you could use the letters or the numbers 1 and 2 instead of writing them out. If a line, because I don't memorize those and I don't expect you to memorize those. And Theorem 311 is different in my other geometry book, and so if I did memorize the numbers, I would be so confused. Thanks, all right. So if you have parallel lines in a transversal that's perpendicular to one of them, he has to be perpendicular to the other one. That's what that theorem says. Two parallel lines cut by a transversal. The transversal is perpendicular to one, it's got to be perpendicular to the other one. Okay, next proof. No, Rashid just asked that. No. Because they're two different geometry books, so they just number the theorems differently. All right. Anyway. Number 2, given A is perpendicular to S, C is perpendicular to S, and A is parallel to B, we're trying to prove that B and C are parallel lines. Once you have the given written, you have to mark that on your picture. A perpendicular to S means where they intersect, they make a right angle. Got it. C perpendicular to S, where they intersect, it creates a right angle. And lastly, A is parallel to B. I want to try and prove that B is parallel to C. You have a bunch of ways. You have 7 ways. They're up there. Wiggly. 2 and 3 are corresponding angles. Do you guys agree 2 and 3 are corresponding? Well, I agree with you. So, Wiggly, if we could prove that 2 is congruent to 3, would B be parallel to C? Okay. Let's try and do it then. Let's try and say 2 and 3 are congruent angles. So I got to prove that 2 is congruent to 3. Kilgore. Okay, what theorem are you using? Oh, okay. You agree that A is parallel to B? I could do this. Could I do this? Angle 1 is congruent to angle 2. Because if lines are parallel, corresponding angles are congruent. You guys agree with me? Thanks. But I want to say 2 and 3 are the same. What kind of angle is angle 3? How did we know it was a right angle? Because the lines were perpendicular. What kind of angle is angle 1? 90 right angle. How did we know that? The lines were perpendicular. Step 3. Those are 90-degree angles by the definition of perpendicular lines. In the given, the lines are perpendicular. Therefore, we get 90-degree angles. Yep, we will. If 2 angles equal the same thing, then we say those angles are what? Another word that starts with a C? Congruent. Would you agree that 1 is congruent to 3 then? Because if they equal the same thing, then they're congruent, and that's by the definition of congruent angles. Sorry about my mic. So Riley, in step 2, 1 is congruent to 2, and 1 is congruent to 3, so by substitution, we'd say 2 is congruent to 3, yes?
Like, you know what I'm saying? Because it's perpendicular to those lines, and then 1 and 2 are parallel, and 3.
Okay, hold your thought. Just mumble quietly in your head for a second. Wagley, since 2 and 3 are congruent and corresponding, what does that say about B and C? They're parallel. 6. B is parallel to C. If corresponding angles are congruent, then the lines are parallel. Remember, in your reasoning, the conclusion, the part that follows then, should match what you're telling me in the statements. We're saying lines are parallel, so I conclude with that. In step 2, we were saying angles were congruent, so I concluded with that. Okay, I'm going to give you 4 more seconds to finish writing it down. You're at 2 more seconds. 1. Oh, don't you dare close that up. We're not done. 3/4 of a second. Maybe now to a half. She's taking a really long time. All right, good. So, Riley, what do you mean we could have done it in fewer amount of steps? 1 and 3 are both right angles, which we did because we had these perpendicular lines in the given. So I have A perpendicular to S and C perpendicular to S. If I have 2 lines, A and C, perpendicular to the same line, what do I know about those 2 lines? Look at Theorem 310. Because I just did it right 10 seconds ago. What's Theorem 310 say? They're parallel to each other. Don't we use like L, M, and K instead of A, S, and C? Are you looking there? Because some of you are looking at me. 2 lines perpendicular to the same line are parallel. Since A and C are both perpendicular to the same line, we can say A is parallel to C. Reason? 2 lines perpendicular to same line are parallel. So now, you guys, and that's not what we're trying to prove. What do we try to prove? B and C are parallel, right?
Yeah,
A is parallel to B, and A is parallel to C. If I have 2 lines, B and C, parallel to the same line, what does that say about those 2 lines? They're parallel. 2 lines parallel to the same line are parallel. Step 3, B is parallel to C. Why? 2 lines parallel to same line are parallel. Did we get to what we were trying to prove? I wasn't leading the proof. You guys were. Why are you so upset about? Was the first one wrong? Absolutely not. It just took longer. It doesn't matter. It's however you see it. The more theorems you know, the fewer steps in a proof. But did you have to know these to prove it? Absolutely not. If you like these 5, then stick with those 5. All right? Okay. If you want to write that down below it, maybe you do, so you have something to refer to for your homework.